Flipped classroom on titration, and we're going to talk about what happens when you have an acid and a base and you're trying to neutralize one with the other. Now, if you recall from one of the previous videos, a neutralization is when you add enough acid or H plus ions to a base or H minus ions in order for that they cancel and make salt and water. So a titration works on that principle, but it's a mathematical formula, and it is adding a measured volume of an acid or base of known molarity until the neutralization occurs. Or in other words, you're taking a certain amount of acid and a certain amount of base, and you're seeing how much you need of one to cancel out the other. So an example would be if I were going to add 20 milliliters of 1 molar HCl, which is hydrochloric acid, and I use it to neutralize 20 milliliters of 1 molar NaOH, which is a base. Now, this should be pretty obvious. If I told you I had 20 milliliters of 1 molar acid, how much 1 molar base would I need? Obviously, I would need the same amount. I'd need 20 milliliters. What you need to understand is why that's a neutralization. So the reason why that's neutralization is because of this formula right here, and that is HCl plus NaOH makes NaCl and water. Or in other words, acid plus base makes salt and water. And again, if I have 20 milliliters of 1 molar acid, then obviously I'm going to need 20 milliliters of 1 molar base in order for it to be neutralized. If you look at this equation, it is nothing other than a double replacement reaction, because what's actually happening is the H and the the H and the Na are switching places. The H becomes part of this, making it HOH, and the Na joins to this side, making it NaCl. Now the next thing I want to do is I want to show you something called the titration equation. The titration equation is actually in your reference table. It's on table T of your reference table, which is the very last page of the chemistry reference table. And here it is right here. Hold on. Right there where it says titration. Titration is Ma times Va equals Mb times Vb. Now, what do all these letters mean? Well, M is molarity and V is volume. Ma is the molarity of the H plus ions, which means the molarity of the acid, and Va is the volume of that acid. Mb is the molarity of the OH minus ions, or the base, and Vb is the volume of that base. So again, Ma times Va equals Mb times Vb. Now I've also written it right here on my paper so you can see it. Ma, molarity of acid, or H plus, times Va, volume of acid, is equal to Mb, molarity of OH minus, which is base, times Vb, molarity of volume of base. So why does this equation work? Well, it works on one very simple principle. If you multiply molarity times volume, you get moles. You might remember that when we did the solution chemistry chapter. So Ma times Va is technically moles of acid. So let's say you had exactly 10 moles of acid. How many moles of base would you need to neutralize it? Well, that would be no surprise. If you had 10 moles of acid, you'd need exactly 10 moles of base. And Mv times Vb means moles of base. So moles of acid equals moles of base. If I had 10 moles of acid, I'd need 10 moles of base to neutralize it. So let's do an actual MAVA problem, something that you might find on a test. So in this example, let me clean it up a little bit. In this example, I'm asking how many moles of 0.2 molar NaOH are required to neutralize 50 milliliters of 0.1 molar HCl. And as you can see, we're going to use the formula MaVA equals MbVb. Now, what do I plug in for these four symbols? Well, again, Ma is the molarity of the H+, which is the molarity of the acid, and that's 0.1 molar. Va is the volume of that acid, that's 50 milliliters. So scrolling down here, it's going to be 0.1 times 50 equals, now what's Mb? That's the molarity of the OH minus, or the base, and the base is NaOH, so that's 0.2 molar, so I put it right there, which means all I need to solve for is what I was asking for, the milliliters of that base, which is going to be X. I don't know what it is, I'm going to solve for it. So 0.1 times 50 equals 0.2 times X. If you pull out a calculator and solve for X, you will get X is going to be equal to exactly 25 milliliters of NaOH, 25 milliliters of base. Relatively easy problem. Most of these problems are. You just have to solve for X, and usually the X is either a VA or a VB. It could even be an MA or an MB. It doesn't matter as long as you have the other three numbers. You just plug in the X and solve for it. There's only one way that I found that this problem can be a little bit tricky, and I'm going to show you that right now. What if the acid or the base has more than one H plus or OH minus? In other words, what if I'm titrating an acid that has 2 or 3 H plus ions, or a base that has 2 or 3 OH minus ions? Well, now I have a problem because I just said that I wanted the moles of acid and base to be equal, and if I wrote it down as a stoichiometry, they wouldn't be. So let's try this example. How many milliliters of 0.2 molar AlOH3, and notice that has 3 OHs, are required to neutralize 50 milliliters of 0.1 molar H2SO4. And notice that acid has 2 H's. So these aren't equal. In the previous problem, there was 1 H and 1 OH. Now I have 3 OHs right there and 2 H's right there. So first thing is I'm going to rewrite that so it's clear. You can see, note, H2SO4 clearly has 2 H plus ions, and AlOH3 clearly has 3 OH minus ions. So I'm still going to use the same formula, but I have to adapt it a little bit because, as I just stated, there are more H's and more OH's. So here's how I'm going to fix the problem. Give me 1 second to adjust. Therefore, we must multiply the acid side by 2 and the base side by 3. Now, how do I know to multiply the acid side by 2 and the base side by 3? Again, I just said the H2SO4 has 2 H pluses, and the base, the AlOH3, has 3 OHs. So the acid side gets multiplied by 2, the base side gets multiplied by 3. So my new formula is going to be slightly altered. It's going to look like this. Instead of just MAVA equals MBVB, I'm going to say, all right, MAVA times number of H plus ions is equal to MBVB times number of OH minus ions. So pulling down everything now, the number of H plus ions in H2SO4 is 2. So I put a 2 there. The Ma is still 0.1. That hasn't changed. We had that before. I'm going to show you. 0.1 molar H2SO4. The volume of that acid was 50. Again, I'm going to go back and show you. The volume was 50. See, 50 milliliters of 0.1 molar H2SO4. The molarity of base, Mb, is 0.2. Again, right there, 0.2 molar AlOH3. The volume, X. We don't know. It's saying how many milliliters. We're trying to solve for that. But there are 3 OH minus ions. So it is 2 times 0.1 times 50 equals, hold on, let me make that equals more clear, equals 0.2 times X times 3. And now it's nothing more than an algebra problem. You just have to solve for X. You have to divide or cross multiply. You have to figure out how to solve for X, which I know your algebra skills are good enough to do this. And if you solve for X, you will get X is equal to 16.7 milliliters of AlOH3. And that is how you do a titration in acid-base chemistry.